until it burns. Be your wings you never could chase. Always knew that it's a memory, basic, yeah. We'll go on then, echo rise. Take your time. You'll never go through it. After this, I'm gonna eat, bro. Tired. Not tired, I just need food, bro. Go on then, go. I think it'll refresh on its own. I don't think I need to do anything. Hopefully I can just do better than what I did last time. I'm trying to break that 1600 mold, bro. I just can't, you know? Excuse me? Okay, here we go. Given an array of strings, names, and an array heights that consist of distinct positive integers, both are of length n, for each I, names, height, denote the name and height by the people's heights. Okay. I already have an idea. I mean, this might be kind of crazy, but like, here's actually what I'm going to do. For const, actually, I ain't going to do that. I just want to access it, right? I less than, you already know what length is. Just to be extra, you know, names dot length or whatever, that's fine. Alright. I plus plus, sure. And then what we're going to do is we're going to take a table. And we're essentially going to take table, we're going to put in heights I equals names I. And with that, we can actually, I suppose we can sort it if we want. So we can take heights and sort it, right? So heights, I don't think we have to do equal. We use height. Let's sort A, minus B, and then the output is an array, right? So what we can do with this sorted information is now we can just so for every height of heights, what we can do is we take that height. So yeah, we're going to go ahead and take that height. We're going to access, so we're going to push, instead we're going to push names. But how are we going to, so sorry, we're actually going to push the table. And then what we're going to do is we're going to give it the height, right? So, you know, we'll do the sorting, whatever, and we'll have like, this is just for an example's sake. You know, we'll have some fudge. Go on then, echo rise. Take your turn. So you might have like 155, and then it says Alice, and then you'll have 150, and that's gonna say Bob, and then you're gonna have 150, or sorry, you're gonna have this is actually 185. It didn't really matter, but there's 150. Then you go Bob, and what you can do is you can access each height, use that height to access its corresponding name, and then push that into res, and then just return the res. Now let's see how that works with the example cases, yeah? So we get Alice, Bob, but really what we need is, so let me make sure height is sorted in the right way. So let's take a look at heights. I think it sorts in place. I don't think I need to do any like, so for example, at 150. So let's console log heights while console logging table as well, because we have Mary John. So something has gone terribly wrong. So we have 150. and. So table, why is it doing that? You know what I mean? Like, because we have 150, and if we access 150, like, what's heights when we're done here? So like, oh shit, sorry, you're right. No, I just had it the wrong, yeah, there you go. We don't want to do the sort until afterwards, after we've already done it. So that should be fine. Now, what are the guarantees? What is n? You know, like this doesn't work for John though. Okay, so let's see what's happening here. Where is the tallest? So wait, what's going on? So in ascending, in descending order. So 150. Okay, so you actually want to do this way then. Mary, Emma, John, Bob, Alan. So, and then, okay. So what you want to do then, I think, is, let's check. So let's see. Like, how do you handle, like, if you have duplicate? Let's just see what happens if it works. Okay, so it's accepted. I'm not gonna do any extra. It's accepted, right? Let's try another problem since we have the time. Let's try another problem. So let's go longest. Now, man, I'm not very familiar with bitwise operation. I'm actually gonna have to refer to some notes here that I took on bitwise operations a little while back, because I'm not all that familiar. I'd be lying if I said I was, man. I'd be lying if I said I was familiar with bitwise operations like that. So, where's a bitwise function? So not word break, not coin chain. Largest divisible subset, no. Reverse bits, sure. So just have some bitwise operator review on here. So just make sure I know what each does. So you're given an array nums of size n, sure. Consider a non-empty subarray from nums that has the maximum possible bitwise n. Don't even know what that means. Consider a non-empty subarray from nums that has the maximum possible. So consider a non-empty subarray from nums that has the maximum possible bitwise, and don't even know how, like, because let k be the maximum value. I don't know what you mean by maximum possible bitwise and. I don't. What do you mean by that? I feel like the complexity from this problem is understanding what's being asked of me. I don't. It seems like there's a trivial O of n squared solution to this. Yeah, I'm gonna have to draw this out. I don't know what's really being asked of me, if I'm being honest with you. Actually, no, now I know what's being asked of me, I just don't know how to do it. You're looking for the longest subarray, right? With the maximum possible bitwise AND. The bitwise AND being ANDing every element in there, right? So if I AND 3 and 3, well, 3 is 0, 1, 1, and 3 is 0, 1, 1. If I AND that, I'm going to get 1, 1, 1, which is 3. Because AND, actually, no, sorry, I'm going to get 0, 1, 1, which is 3. So, for example, subarray with that value. So looking for the long subarray. Maximum value of bitwise AND of any subarray. And only subarrays. So we need to find, max value of the bitwise and of any subarray of nums. How big can it get, nums? Nums can get pretty big. So if we're talking about creating, I guess it would be permutations. I don't know if we will. Well, combinations, because it'd be the same, right? If it has the same elements in there, it doesn't matter the order. But if I was to create all combinations for nums with a length of 10,000, that's just not even 10,000. We're talking 100,000. I don't know about that. Find maximum value of bitwise AND. So find max value of bitwise AND of any subarray of nums. Then find the longest array with that maximum value of bitwise AND. That maximum bitwise AND. So I'm intrigued by this one. Thoroughly, I am. It's not clear to me how this gets solved. It's not clear. What can I do? So let's say we ANDed 1 and 0. Sorry, 1 and 2. The solution I'm thinking of is going to be too slow for 100,000. Max call stack is going to be exceeded. I don't know how to do this. Legitimately, I don't know. Legit, I have no idea. I think I'm better off trying to solve this than the other one. I ain't gonna cap. That bitwise is kind of strange. I don't know how to do it efficiently. Like, the solution I have is not gonna work for, if n gets as big as 100,000. It's just not. There's no way. So if we look at 2, we see, okay, k elements. So 2 elements before are in loosely decreasing order, which means it can go 2, 2, 1 if it wanted to, if k was 3. Just after in loosely increasing order, it can go 1, 1, 2, if it, you know. So 2, 1, and 1, 1, yeah, sure. So if we look at index 4, sorry, yeah, so if we look at 4, look at 2 elements. This is fine, but this is not loosely increasing. It went from 4 to 1, right? So this, at least with this, I can see what's going on. And in the range that, okay, well, I is greater than or equal to k, which makes sense now. Now it makes sense. I needs to be greater than or equal to k, so we can look at k elements before it. So that makes sense. Okay, sure. It wants all the indices that are good. So essentially, yeah, interesting. Length 3, 6, 7 minus k, 5, which makes sense. So if we're ever here, we need to end. So we need to make sure while we're within range, right? So our start actually is going to be k. Whoa. We're going to start at k. So we can look at 2 elements before, right? And then our end is actually going to be nums.length minus k. And in between that, we're going to have our I. The I is going to equal start. Right? So while I is in between those two, so we look at a nums length. This has 7 elements minus 2. So once we get to 0, 1, 2, 3, 4, if we get to index 5, we're no longer good. Right? So we need to make sure while I is less than end. So also while I is, well, really that's all we have to do, because we're already starting I at start. You know, we're already starting it at 2. You know, and so that should be fine. And what we're gonna do is, and we can also slice. I think it's kind of do this efficiently. I have an idea, but it's not efficient really. But let's see. So we'll have our, that person is going crazy with that card, man. It's going crazy with that card. We can actually flip it. And we'll start this actually at start as well, except R is going to go boop boop. And these aren't going to change. So I might as well have them called. They're not going to change. We're literally, like, we're going to start here. And we can look this way. What does that mean, though? So it's also valid if you have 2, 2, 1, right? Or if you have 2, 1, 1. So all we have to do is make sure that we are loosely increasing from right to left. So if we wanted to move from right to left, ensure that it is strictly increasing. And if we want to move from, so so right to left, so from, I guess it's left to right. Ensure that it is not strictly, loosely decreasing. So when we start here, no. We also need to check that is. So here's what I'm saying. I'm saying if I'm here and I want to start from there and start moving to the left, I need to make sure that these are loosely increasing. Right? You could say 2 to 1 is a non-increasing order, which means it's in loosely decreasing order from left to right. But if you're going from right to left, it's in loosely increasing order, right? And then here, as normal, you can ensure that this is also in loosely increasing. That it's loosely increasing, right? So what you would do is you would take the index that you're on. You would say. So you would actually do for let so you would essentially want to move from start. You would essentially want to move from start, which is at 2, to start minus k. Right? So I don't even know if it's clear that you would need something like this. I mean, you could let L equals start, while L is so moving from 2 to 0, while L is greater than or equal to start minus k, L minus. All you have to do is ensure that it's strictly, so for example, we can just make sure so we start at 2. Actually, it doesn't even matter, does it? You're looking at these two. You're not looking at that. So you actually start minus 1. You start at 1. And you say negative infinity, and you say if nums at I, so if nums at I is greater than lowest break, else lowest becomes nums at L. So what does this mean? I'm looking here. My lowest is, sorry, this is actually be, my lowest is negative infinity. You want to see, if I is lower than my lowest break, if it's not, then set my lowest equal to 1. Then we're going to go again until start minus k. Start is 2 minus k, so all the way up to 0. And so once we're at 2, we want to see, okay, is 2 less than lowest? If it is break, if it's not, then lowest is equal to, it's not so much that we break though. That's not it. That's not purely it. We'll set it equal to true first. Then boom, that's it. loosely increasing already, then just move I up and continue. Don't even look at the next one. If one of them breaks, then just, else we're going to say, so is, or we can say is left half valid. And then we'll say if left half is not valid, then just go up, right? And we'll say is right half valid equal to true. We're essentially going to do the same thing, same sort of functionality here, where we say, okay, we're going to let R start at S plus 1. All right, so we're going to start from here to here, and while that's less than or equal to start plus K, R plus plus, and we're going to say essentially the same thing, 1, 3. I think that's the general idea. You can do a res.push I, and then regardless increment I. I think that's the general idea. And this is just short circuiting, where it's like if left half is not valid, you don't even need to check the right half, seriously. Now, let me return res just to see what I get. Who knows? I could be on point right now. Doubt it, but I could be. Oh yeah, you're right. Make sure everything else is good. Okay. So we're given 2, 3, 4. Oh, almost there. Let's see. Now, how did we get? So how is 4? It's not ridiculous. So we're starting off at infinity. And we're seeing, and let's be clear, so start, so we're going 3, so let's see, we'll be at 2, we're gonna check, so sorry, when we get to this case, we'll be at 4, right? I don't think we'll want to start. So I don't think it'll be start, really. I think it'll be I. Yeah, we want to keep it moving. We wouldn't want to be start, I want to be I. We want to keep that shit moving. Nah, I think that's on this. I think we're on to something. I don't know how fast it is. Let's see, is it correct? I doubt it in terms of speed. Yeah, no, that's that time. Oh, accepted. Okay. Slow, but accepted. Slow, but accepted. And so you see, the idea was, if we go down this way, sure, we can make sure it's in non-increasing order, but we can just start from here, start from where I is, subtract 1, and make sure that for k elements, it's actually loosely increasing, and then back starting from I, look to the right, and see that these, like 1 and 3, are also loosely increasing, right? And so that made sense. And now, again, I don't think it's all that fast, right? I tried to short circuit here, but ultimately, I don't think it's all that fast. But I mean, I'm glad I'm one of the people who were able to do it. That problem felt more intuitive to me, actually, than this problem, because I don't use bitwise operators or operations ever, even right now, I don't know how to solve this problem. Let's see, I might be able to solve the hard problem before I solve. Dude, I need to get more familiar with this. I need to stop doing that. I might be able to solve the hard problem before I'm even able to solve that one. No way you're representing a tree like this. That's actually kind of insane. There is a tree. Okay, wait. Before I do this, that's because I hate the fact that I've left this out. Let's see if I can do it. Let's just see if I can do it. Let's see. It's not. Maybe it's not as difficult as I think. The problem would be, maybe. Can I solve it efficiently? I think that would be my issue. I don't think I can solve this efficiently. I really don't. I don't see it. But maybe let me stop complaining and actually look at it. Man, I'm fucking hungry. I just said I'd stop complaining. God. Fucking chocolate bar. Fuck with me. Are you kidding me? Find max value of Bitcoin and follow this array with max value. How much time we have? Got about 50 minutes left. Okay. Can I solve this? Of a subarray. What's it saying? Oh man, this is a big part that I missed. I was like, am I creating combinations? Fuck! I glanced over this part. Dude. Contiguous, right? So 1, 2. So 1, 1, 2, 1, 2, 3, 1, 2, 3, 3, 1, 2, 3, 2. And then this way, right? This is said contiguous. Shot, come on, focus, dude. Fucking skip that shit, dude. That's big, dude. That's big. Tripping. Sorry. I'm like, wait a minute, that's not contiguous. Dude, I brute forced the hell out of that one problem though. Like, I know I'm gonna have to look up a solution after that. Like, that was. But hey, this is gonna be like looking at it, we can kind of see it's gonna be an n squared operation, but. So I not, yeah, this is going to be n squared, I believe so. But I don't think there's another way to do it. Unless there's some like sly dynamic programming trick I'm not aware of. unless one of you bastards is hiding some very slick dynamic programming, I don't know. There isn't even a for, dude. I'm not even locked in, bro. I swear to God. For doesn't even exist, bro. What am I doing? Yeah, I'm not even gonna. Let me tell you how I'm gonna do this. You guys ready for this? I'm not wasting my time with this. I'm really not. Here's what I'm gonna do. I'm gonna create a function to calculate. Get calculate bitwise. I'm gonna take a specific array, right? I'm gonna and every element in there. So how am I gonna do that? If I wanted to do that, just simply not even. So say I had like 1, 2, 3. How am I gonna do that? That's the big question. That's the big ticket, right? How am I gonna do it? So maybe I have like some. The result is 1. I need an and 1. Let I equal I less than dot. Let's just do a naive. Let's assume this is how we need to solve it, right? So result is going to equal result and. So we take 1 and 2, which is actually going to be 0, 1, and 1, 0, which is going to give us 0. And if you and anything with all zeros, you're going to get all zeros because, yeah, so this should be 0. And then return result. Let's just test it. Calculate bitwise with 1, 2, 3. Let's just test it and see what happens. We should get 0. Okay, so maybe I should do something that isn't gonna give me 0. So let's try it. Actually doing like 1, 1. It's gonna be this, that gives us our 0, 1. And then we're gonna and that with 1, 1, which should end up giving us just 1 as the output. So yeah, so we're good. So then we can use this and basically just extend. So this is actually going to be an n cubed. You get what I'm saying? This is going to be n cubed. Whoa. I don't know if we're ready for that. This is going to be n cubed. This is not going to be fast at all. This is the trivial of trivial solutions. This is like I am in 2nd grade type of solution, but I have an idea. And, I'm going to do something with it. My thing is, okay, let me keep track of a max then. And what max is going to be the maximum that maximum bitwise and so we're gonna go through every element in there, and for every element we're gonna go through every element. Actually, I have an idea, not too bad. Let's just populate. Let's populate res first. Like, let's do res.push. Okay, what are we pushing? Nums I in there, sorry, excuse me. So we push nums I in there. So we're gonna call it I'm going to do a res.push to results. We're going to do it to sub arrays. And then we're going to go through the subarrays. So this is going to be an O of n squared. I'm not going to actually do the calculate bitwise inside of here. I'm going to have 2 nested for loops. I think is a decent idea. I'm running out of I don't know how to do this efficiently. I just don't know how to do it efficiently. I'm not going to pretend like I do know how to. I don't know how to do this efficiently, bro. I don't. So, you know, because we had to subarrays, push subarray, and then what we're gonna do is we're gonna keep pushing to our subarray. So subarray.push nums and j, and then once we do that, we're also gonna push that into subarray. So we keep pushing that, you know. So first we probably want to start. If we're gonna do it this way, we probably want to start at I+1. And then we're going to push that into subarray. And let's see what we have after that. Now, you saw how crazy this was with just these. Ooh, we don't want to imagine how. Oh my. I'm fucking something up. What'd I do? What happens if we do that? Yeah, I think that fixes our issues. Because, you know, we have memory references everywhere, and, you know, yeah, I had a feeling that would fix the issue. Just my premature premonition. So good. We have all of that. Now for all of these, we can go ahead and calculate. So with this information, the thing is, dude, this can get really big, bro. That's not gonna work. It's not. Dude, that's not gonna be fast enough, bro. I can already see it. We can have 100. It'd be different if we can have like 1,000, you know, 10,000 maybe. 100,000? I feel like you're gonna have to actually use like bitwise manipulation, like in a clever way to do this. It's just too brute forcey. I mean, it worked with the other one. Don't think it's gonna work with this one. I just don't. Let's see what happens though. You never know, right? You never know. So, what can I do from this point? So from this point, we can store information. So we can store our own table. You're like, why are we gonna use a table? I'm gonna go through every single array of subarrays. I'm going to calculate bitwise on each one. This is why I said this is going to be very expensive. And calculate each one. The result of this is actually going to go in the table. Right? With then let's look at table. So, oh, forget this. We're gonna map to each. So what you can do is you can say max val calculate bitwise with array, and you're gonna see you're only gonna put the biggest one in there. So you're gonna see if max val exists in there. First you want to check does max val exist. So first you want to check if max val is in table. And if it is, then you want to check if table max val dot length is greater than. So you want to see if it's less than or equal to array.length. Or if you want to see if array.length is greater than, that's one, greater than table max val.length. If it is, table max val max val is going to be equal to array, and then we can globally state that the wait, what? If that value is 3.3, wait a second. What are we doing here? I don't even think I need to do all that, bro. We don't even have to do it. max is? Max is 3. So you're looking for the longest contiguous sequence of 3s. This is terribly slow. That's what I'm saying. Because now I'm going to have another for loop. Right? To see if we can find the longest sequence. So this is... So essentially what's going to happen is we're going to keep moving L and actually calculate window length too. So we're going to keep moving these things. Good lord. This is the bottleneck right here. We're going to keep moving L and R4. Boom, 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 boom. And then, if we see, we keep moving on. Let's say window. This is going to also be negative infinity of window length. So sorry, of R minus L plus 1, window length, that's what it's going to give us. Then we're going to set L equal to R and start from there. And then we're going to return window length. This is crazy, Chuck. My thought process is very crazy sometimes. Now here's the thing, here's the issue. Let's see what R is here. So we say, okay, our R is 1, so our R is so we check to see if we're, if R, we don't want to increment yet. We check to see if we're equal to max, or we're not. So we're gonna increment R actually, and say L is equal to R, ensuring that. So we increment R, boom, we say L is equal to that. So we check again, nothing. So we see like, okay, well, R plus 3 and L is equal to R. So here we go. And then we say, well, no, it's R is equal to max. So we increment. And then we say, it's equal to max again. So we increment, right? So that puts R when it's all said and done at 4. L is still chilling at 2. And what that does for us is if we take, we don't even need to do +1, I don't think. And we can just move this up. So we'll calculate the difference between R and L. When it's all said and done, we'll move from index 3 to index 4 to realize they're no longer equal. L is still here. We can just subtract R. We can subtract R, which is 4, with L, make it 2. The max of 2, or the window length is -3. So then we move R forward. Which, I mean, if this is not equal, then that's fine. We can move R forward. And we move L to R. Yeah, that should be okay. That should give us 2. Right. Now, we say, for this example, will give us 1. So it gives us 1. I am not in any way, shape, or form confident this is going to work. We're not even guaranteed an answer. So what's going to happen when we're not guaranteed an answer? I don't think you want me to return negative infinity, do you? So I think if there's no longest array, let's not start at negative infinity. Let's start at 0. Let's do that. Now, I think time. Yeah. Heap add JavaScript. Yeah, something's gonna. I don't have a solution for this. I don't. I'm okay with saying I don't have a solution for this. I'm going to conclude today's contest and get some food to eat. I'm trying to push to be able to get, consistently these first 3 problems if they're easy and medium. But I think that's fine for today. I'm gonna get some food, man. Hungry.